I say that in the video too. But yeah, so so I went and I pursued dance. I was when I was in New York, really hard. So I did the Rockettes, and I did a show called A Chorus Line at the time, and it hit a point where I said, okay, it's time to go back. So I had learned about engineering, so I went back to school at Caltech in Pasadena for aerospace engineering. And I started to learn that I really loved this big picture idea. And I took a job in systems engineering at SpaceX. And so when I was at SpaceX, I learned about systems engineering and how important that is to the spacecraft and to the whole mission. It felt like it really hit home for me. That was something that I could really relate to. And so then through friends and resume passing around some things, I ended up at JPL eventually. But those are kind of the journey of how I got there.
And for anyone watching who really has a passion for science and art like you do, what advice would you give them when they're kind of trying to decide their career path and how to balance both?
Oh gosh. So I guess to never give up on either. I think what I've found is I've had to maintain and find a balance as I've gotten older. So every time I find that I've gone without dance or singing for a while, I kind of get sad and I need to find a dance class to take, or I'll sing at home with my husband or something like that. And equally, when I had pursued dance so hard for so long, I really found that I missed research and I missed learning about space and my passion for space. And so as I've gotten older, I've learned you can't let one or the other really take over. And so you really have to maintain that balance. So just never give up on that. I guess there was something else I was going to say along those lines, but we'll get back to it, I guess.
All right, because those were all my questions, and if you get back to it and remember, just let me know. I'm going to get now to the Ask NASA questions and see what people have to say. So Martian Manish on Twitter asks, how is engineering for Mars different from engineering for Earth?
Oh gosh, so this is a fun question. I recently had some discussions with some astronomers. So astronomers have telescopes here that are on the ground. You can access them at any time. And as I was talking to these astronomers, they were saying, yeah, if we run into issues, you just go up to the telescope and you fix the telescope. And I'm thinking to myself, it actually took me some time to realize, oh, you can just go touch the hardware and fix it. Like if you have a problem, that's part of your project. That's just how it works. And when you can send things up to space, you don't get to touch it anymore once it's up there. So you have to consider all the different anomalies and hardware issues that you could run into before you send those things up into space. And that's part of this whole test campaign that we go through. And so there's that distinct difference in your prepping and your planning and your preparations to make sure that you include consideration of the fact you won't be able to touch it anymore once it gets up there.
So that means you almost have to think of every single thing that could go wrong, correct?
Yeah, I guess the term I've heard passed around is unknown unknowns. So there's always this small bit that you keep in the back of your mind of, gosh, there are certainly many unknown unknowns that we haven't thought about. But yes, as part of our team preparations, we're trying to figure out any different thing we can come up with, and that's part of some of the testing that we're doing. And if something does go wrong up in space, and the vehicle doesn't autonomously react to it, then you do have to have operators come in, command the vehicle, and try to get it back in the state that at least a healthy state to get you to Mars. Recently, in one of our anomalous operations tests that just completed, it was a pretty intense 48 hours, we weren't able to even command the vehicle, and so we had to think through the situation of what you would do and how you would fix it. And so we went through a series of different recoveries that we could do in order to command, and we eventually got through it. So.
And I actually have another one from Florian Van Sitters on YouTube, who asks kind of how does the team decide between the scientific benefits of certain features compared to the challenges these pose from an engineering standpoint?
That's a really great question. Sorry, I'm not sure if you can hear it. We have a some car coming in the background.
Oh, yeah, someone decided to show up. It's okay. It's starting to go away now.
Yeah, so it's definitely a trade. So with systems engineering, one of the most interesting parts that I don't think people know about when they sign up for the job is that you're not just an engineer, you kind of become a bit of a negotiator.
So they have a little distortion in the background.
Consider the risks for both of the trades, so that you can come up with not the 100% solution, but maybe the best solution you can come up with at the time. So I think a lot of engineers can think in like a black and white space, but as a systems engineer, I feel like I'm constantly in a gray space where I'm trying to understand how gray this is, how black we need to be, how white we need to be, and then talking in depth to these experts to really know what they know, to understand what I don't know, because obviously there's plenty I don't know, and to be able to get to a place where we can come up with the best solution for the mission.
And then I have another question from Ahmad Hamur. I don't know if you know this, but how long do we expect Perseverance to last on Mars?
Gosh, I don't want to get it wrong. I think it's about 1 Martian year, which is equivalent to about a year and like a handful of months here on Earth. Something like that, but I'm not on the surface team, so I don't know the details, but that's about the length.
So, Ahmad, you can also ask that question to Ask NASA Persevere, and we can get back to you with an answer on that. And he also wants to know, is there any artificial intelligence on Perseverance?
Well, so AI, I think, can be defined in many different ways. I think one of the coolest things about this rover is that it has an ability to navigate with a better autonomous capabilities than the previous rover, than Curiosity. So it's able to identify different rocks and move around those rocks, that sort of thing. But I think that's like the biggest improvement to AI that we have on the vehicle for 2020 compared to Curiosity. But there are certainly a lot of things that we've developed AI-wise for all the rovers. But I would say it depends on your definition, I think, a little bit.
What it is. And another thing that would be new on here, Fletcher on YouTube asks, how do you select the cameras and their angles for the rover, and is it different for science versus engineering cameras?
Yeah, absolutely. There are different engineering cameras dedicated strictly to engineering hazards. They're called the HAZ cams on the rover, and then the nav cams as well, or the navigation cameras. And then each of the instruments, not each of the instruments, but many of the instruments have cameras themselves that are higher resolution, those sorts of things. But you need to consider the different resources that those cameras are taking up on board. So power, data, thermal, anything like that, just to consider how much bandwidth those things are taking up. And so again, it becomes a trade between, well, which science objectives are more important to make sure that we're not in a hazardous situation with the rover. But in terms of the different angles, they're designed so that they're for science specifically or for engineering purposes specifically.
And then Guido asks, how do you protect the circuit boards from flips due to radiation, from bit flips due to radiation?
I probably am not the expert on radiation protection, but I do know it's on board.
So again, we'll defer that to the Ask NASA hashtag and go to @NASA Persevere, and we'll try to get you an answer on that. So Florian on YouTube asks, how does Perseverance Rovers team balance decisions?
So it's a really good question. So a lot of the team comes from the Curiosity Mars rover team. And so what we've found is that there's a balance constantly between how things were done on Curiosity and how we want to make things better for Mars 2020 without adding additional risk. So I think there's a really fine line between making things new and fancy for the sake of making them new and fancy, and using this heritage because you know that it's a heritage design that works. And of course, even with that, there's a risk that maybe the design that worked was some sort of negative or positive, where two things went between themselves and ended up with the positive design. So we have to constantly keep digging into the design to understand how to proceed forward. I don't know if that totally answered your question, but I think in general, because we have the team from Curiosity, it's helped us to really mesh well now as a team for 2020, to have those kind of experts on board, but then also have this new wave of new team members coming in and adding their perspective to the team.
And then Cruise M7 also asks, how does a system engineer work with different aspects like EDL, and if you could define EDL, or electronics, and do you have to be SME in several areas to be able to take on a systems role?
Yeah, so personally, I jumped from thermal systems engineering, or thermal engineering, I guess you would call it, into systems engineering. So I came with a strong background in thermal, and thermal specifically is an area that spans all the different hardware pieces. So I found that adjustment was fine. You don't have to have been an expert in every single field in order to become a good systems engineer. In order to become a good systems engineer, you have to know that you don't know everything and have a willingness to learn, I guess, if that makes sense. I think having experience digging in deep to these different subsystems makes you an even better systems engineer. And certainly, I think usually when they hire systems engineers, they do look for people that do come from some specific background. So hopefully that helps answer the second part of the question. There was a first part of the question I missed.
Yeah, how does a systems engineer work with different aspects like EDL or electronics?
Gosh, how do you work with those different aspects? Well, so EDL is the entry, descent, and landing phase of the mission. So EDL is a systems engineering problem in and of itself, and that includes electronics. And so I think in order to put together things like EDL with electronics, with the telecom system, and all of those sorts of things, the best methods have really been to just dig into them and learn as much as you can. And I don't know, it sounds kind of like a vague answer, but it's really the only way that I've found to be most successful in some of the trades are just learning as much as you can and knowing that you don't know everything. And with that, you learn to talk to people, talk to all sorts of different kinds of people. I think at JPL, there's lots of different personalities, and so you get a flavor. In any industry, there's lots of different personalities. So you get a flavor of how to have those interactions with people and really learn from them. Learn to trust and not trust what people are telling you. Trust but verify, I guess, is the way to say it. So, I'm not sure if I totally answered that, but hopefully it gave a little guidance based on my own experience.
I think that this is a perfect setup for this question that is kind of a follow-up. Elizabeth on YouTube asks, what are some of the traits that are most important for a systems engineer?
Oh, yes, very good lead-in. I think so. Systems engineers, right, the willingness to learn, I think, is a big one. The ability to see this gray space, I think I talked about that before, but to know that the answer might not be black or white, and you might not have 100% or 0%, and to work through those sorts of situations. I guess, I don't know, I'd like to think that you kind of have to be a little bit social, because I find myself talking to people a lot and learning from them, but then also trading information with them. So like if I'm talking to a power systems engineer and I'm hearing them say things about thermal, and I might be aware of the thermal system problems they're having, I can help guide the power systems engineer so that we can all be informed of the problem. I think a lot of it is also guiding the team to have a common knowledge of the system instead of just having team members in a specific rabbit hole and trying to understand their problems that way. Trying to think of like specific things. Really well organized. I mean, do you have to be good at math? Yes. I think you have to be willing to learn and to be very precise. I think that's the most important thing.
And do you think your creative side also played a role in this too? Like what you used to do versus what you do now? Does it see parallels in that?
Yeah, I think, I guess I've given this a little bit of thought in the last few years. When we were orchestrating these tests and bringing these big teams of people together with the system level testing, I found myself kind of acting like a stage manager, you know, bringing all these different people into the picture. I think someone else had mentioned systems engineers are kind of like the producers. So you have to, if you see a problem and one thing is going in this direction, you have to kind of offset that with this. And so it's a constant trade and keeping the system balanced and everything like that. So that's been kind of fun. I guess systems engineering is also really interesting because you transition with the mission. So, you know, you start out in the design phase. So you have to have a specific set of skills for design. When you get into more of the testing, verification, validation of the mission, you know, you have a different set of skills where you have to think about things analytically. And then when you get into the operations phase, that's where you're kind of in a hot seat. And for me, I've always thought that, you know, you kind of feel like a performer when you're an operator because you're like on the spot, and maybe there's not a stage, there's a dark room, but yeah, I'm sure there's some creativity in there too.
I think that's a great answer. And we're going to kind of switch gears here to Marley, who on YouTube, who wants to know, how long does it take to get from Earth to Mars?
Yeah, it takes about 6 months. So for our Mars 2020 mission, we have a slightly longer cruise period than they did on MSL Curiosity. But yeah, it takes about 6 months. We're landing on February 18th. So look out for that.
2021.
Yes.
Are you excited?
Yes, very much.
And then we have another one from Julie on YouTube ask, what's the hardest part of planning big system level tests and getting a mission ready for launch?
I think it's the most difficult, but it's also the most rewarding. I think it's seeing the team come together. Thought in the last planning for launch,